everyone's good to go. So I'm gonna go ahead and get started. I am in the Monday folder, okay? And your learning target is to be able to analyze solubility curves for unsaturated, saturated, and supersaturated. So we've talked about solubility of solvent and solute a little bit before, and we've talked about unsaturated, saturated, and supersaturated solutions, okay? Now we're going to be able to describe them on a graph. Okay, so I'll start off with the simulation and then show you the practice in a bit. But right now, I want to go over the simulation. So when you click on the simulation, it kind of briefs you through some text and is sent. So CO2 is encased into these bubbles, right? And what we want is for our soda to be fizzy, right? We don't want it to go flat. So this simulation takes you through the properties, the parameters that you can change that can alter the fizziness of your soda, okay? So if you click on going to simulation, so just keep in mind of this reaction. If you go to the simulation, there's the reaction down here, okay? The simulation takes you through parameters that you can change, okay? So we introduced solubility earlier. And we talked mainly about solubility of solids, of ionic compounds. So in general, if you want to increase solubility of solids in liquid, you would increase temperature, just like making Jell-O. You can make a supersaturated solution by heating it up. And then we ended the class talking about, well, what does that do to gases? Okay, so keep in mind the differences between solubility of solids versus solubility of gases, because gas behavior is very different than solid behavior. Changes in any of these will change the gas behavior. So really understand on a conceptual level what's going on, and on a graphical level what that would look like. That's your learning target today. Okay, so there's a lot here that you can explore. So I'm going to give you guys time to do that. So this is called a solubility curve. So if I ask, what is the solubility of sodium nitrate at 40 degrees Celsius? That's along your x. And that means how much sodium nitrate, what I'm really asking is how much sodium nitrate can I dissolve? And the way you answer this is you use this graph, you look at 40 degrees Celsius, you go up until it hits the line. Okay, it hits it right there. So then you go across and you figure out how much that is. That's about here. I see a few answers in the chat. Go ahead and answer if you know what that is. On the graph, if the condition is along any point of the line, it is called saturated water. So how much is that? Chantal, what do you think? What is the solubility of sodium nitrate at 40 degrees Celsius?
It would be 105 grams?
Yes, that is exactly right. And I am glad you gave me the unit as well. It is 105 grams of sodium. Okay. I could also ask you, well, how do you make an unsaturated solution of sodium nitrate? Any point along the line of any of these solids, that's the saturation point. This is the saturation curve. How do you make an unsaturated solution? Let's see. Kaylee, what do you think?
Put less than 105 grams of say at 40 degrees Celsius.
That's exactly right. You make it sound so simple. It makes it sound so obvious. Yes, at any point. So in other words, okay, so at any point underneath any of these curves for those substances would be an unsaturated solution. Perfect. So you know what my next question is going to be, right? So how do you make, I'm going to ask it, how do you make a supersaturated solution? Alex, you're right. How do you make a supersaturated solution of sodium nitrate at 40 degrees Celsius? You guys want to all answer at once? Yes, any point above 105. You guys are so smart.